Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 2594, minimum time to repair cars. You are given an integer array, ranks representing the ranks of some mechanics. Ranks of I is the rank of the ith mechanic. Okay, a mechanic with a rank R can repair n cars in this particular time, R times n square minutes. Okay. We are also given an integer cars representing the total number of cars waiting in the garage to be repaired. Okay. Return the minimum time taken to repair all the cars. Okay. The one thing is basically not all the mechanics can repair the cars simultaneously. Okay. If the mechanic 1 is repairing the car, then mechanic 2 can also simultaneously repair a car, 3 and so on and so forth. All the mechanics can work simultaneously to repair the cars. Okay, so here if you see the ranks array, so the first mechanic rank is basically 4. So if he has to repair one car, okay, let me jump back to my editor and let me explain you. Okay, so these were the ranks of the mechanics, and they have also mentioned the total number of cars are 10, right? So the first mechanic, if he has to repair, okay, if the first mechanic, if he has to repair a single car, then the time taken will be 4 times 1 square, then he will take 4 minutes to repair a single car. Okay, the same mechanic has to repair 2 cars, then the time taken will be 4 times 2 square, which will be 4 times 4, which is 16 minutes. Okay. The same mechanic, if he has to repair the 3 cars, then the time taken will be 4 times 3 square, which is 4 times 3 square, which is 9. 9 4s are 36 minutes. Okay, so this is the time taken for the first mechanic to repair the respective number of cars. Okay, so meanwhile, when the first mechanic is repairing, the second mechanic also can repair the respective cars. Okay, the rank of the second mechanic is 2 times. If he has to repair one car, then it will be 2 times 1, which is 2 minutes. Okay, if he has to repair 2 cars, then the time taken will be 2 times 2 square, which is 2 times 4, which is 8 minutes. Okay, and if he has to repair, let's say 3 cars, then it will be 2 times 3 square, which is 2 times 9. 9 2s are 18 minutes. Okay, so let's say at a particular given point of time, let's say after 18 minutes, let's say after 18 minutes, okay, if you observe the first mechanic standalone can repair 2 cars and the second mechanic can standalone can repair 3 cars. Okay, if I consider only these 2 mechanics, if they are repairing alone, okay, standalone. Okay, so the idea here is basically the number of time taken, let's say T is equal to number of cars repaired times the rank, right? This is the constraint which they have given. Okay, so the overall time in which all the cars can be repaired will be, if I consider, we have to basically see the rank. So for a particular mechanic, the time taken is directly proportional to the rank and directly proportional to the total number of cars. Okay, let's assume the number of cars are fixed. Okay, in our problem we are supposed to repair 10 cars. Okay, if all the mechanics are supposed to be repair the car standalone, okay, let's say first mechanic has to repair 10 cars standalone, second has to repair 10 cars, third has to repair 10 cars, fourth has to repair 10 cars. So the maximum time taken, okay, by one of these mechanics would be the maximum rank times the cars which are getting repaired. So the max time would be equal to max rank times the number of cars square. Okay, this is the maximum time we can go up to. Okay, and what would be the minimum time? Minimum time, if the rank is minimum, then obviously the overall time taken will also be the minimum. So what could be the minimum rank possible as per the constraints? Okay, if you see as per the constraints, the rank of a particular mechanic can minimum can go up to 1, right? Okay, so 1 times the number of cars squared. Okay, so minimum number of cars can also be 1, right? So the minimum time will be 1. Okay, so we will be having a timeline which will be basically from 1, this is minutes timeline, let's assume that this is the minutes timeline, 1 till the max time. Okay, so our aim is to identify the minimum time taken. Okay, our aim is to identify the minimum time taken to repair all the cars. Okay, so in the worst case it can actually go up to max time, in best case it can go up to 1 minute, right? But we don't know what exactly is the answer. So for any given time, we'll actually check what will be the total number of cars can be repaired at, for a provided time. Okay, so let's say we have been given a time t. Okay, let's assume a time t. Okay, for a given time t, I have to identify max cars repaired, maximum cars repaired by a mechanic. Okay, how can I identify? We know that this is the time taken. We know the in the formula we know the left hand side value, which is time taken. Okay, we also know the rank of the particular mechanic, right? All we have to do is to identify the number of cars he can repair. Okay, so n square would be equal to t divided by r. So then n will be equal to square root of t divided by r. So this will be, these many cars can be repaired by a mechanic of rank r in time t. Okay, so all I have to do is basically for all the mechanics, right? I have to identify where I will go from first mechanic till, let's say there are x number of mechanics. Okay, then x number of mechanics. So I have to basically do the summation of all this. So this is basically the total number of cars which can be repaired. Okay, this formula will tell me total number of cars which can be repaired in time t. Okay, if I know the time t, so this will be the maximum number of cars which can be repaired in time t for all the mechanics. Okay, so if let's say these are the cars, let's say hash c. Okay, these were the total number of cars which got repaired in time t. Okay, if I can repair, let's I'm giving an example. Okay, if I can repair 10 cars, okay, in 15 minutes, okay, then obviously I can repair the same number of cars in 16 minutes or 17 minutes or any time in the above. Okay, right? The same number of cars if are repaired in 15 minutes, if 10 cars are repaired in 15 minutes, the same mechanics can repair the same number of cars in any time which is higher than the 15 minutes, right? So I have to basically check, is there any time which is lesser than this, right? This could be my one of the potential solution, right? If I can repair 10 cars in 15 minutes, I have to check whether I can repair lesser number of cars in whether I can repair same number of cars in less number of time. Okay, so the idea here is to apply the binary search in this particular time range. Okay, from 1 to t. Initially we will be identifying the mid. Okay, if I can repair the given number of cars in this particular time, that means this could be my potential minimum time, but I should also verify whether I can also repair the minimum number of whether I can repair the same number of cars in a lesser time or not. In that case, I will be basically updating my right pointer, keeping the left pointer as it is. Okay, then I will actually search in the left space, and so on and so forth. If it is allowed, if it can be repaired in the in the given range, then again I will check for the lesser range. If it is not repaired in a given range, then I will basically check in the other range. Okay, so that is the thought process behind this particular problem. Let's actually jump back to the editor and try to solve this problem. Okay, as I mentioned, the minimum and maximum uh, are basically, min is basically 1 and max time is basically the maximum rank times the n square. Okay, which is basically the total number of cars. Okay, so the minimum would be 1. Okay, let's define the long left, which is actually 1. Okay, and the right would be the maximum of my ranks. Okay, maximum of my all my ranks times the cars, where cars is basically the total number of cars which are there. Okay, here, so ranks times so I'm basically including this for the typecasting because this is integer. Okay, let's define a function called max, which will basically take ranks and which will basically return the maximum. Okay, so let's say the max rank initially is -1. Okay, since all the ranks are from 1 till 100, I'm just defining it as 1 -1, or we can also define it with 0, or you can also initiate with the first element. Okay, it won't be a problem. And let's say for each rank in ranks, okay, max rank would be the maximum of max rank comma the current rank. Okay, in the end I have to return my max rank. Okay, now I have got my the left range and I also got my right range. All I have to do is to apply the binary search over here, right? So while left is less than or equal to right, okay, so I have to I should basically identify my mid, which is left plus right divided by 2. Now that I have identified my right, okay, now I have to check, okay, for a given time, okay, for a given time can I repair the given number of cars. Okay, so as I mentioned, I have the total I can identify for a given time what will be the number of cars I can repair. Okay, if I can repair, if the number of cars which can be repaired, if it is greater than or equal to given number of cars, that means I can actually repair all the cars which needs to be repaired, right? So all I have to do is to calculate the number of cars which can be repaired for a given time t. Okay, so can repair. Okay, let's have a function called can repair, which will actually take the ranks and it will also take the total number of cars and it will also take the time, which is actually mid. Okay, let's try to write this function first. Public boolean can repair, which is taking ranks, which is taking cars, and which is also taking the time. Okay, long time. Okay, for a given time t, I have to identify total number of cars I can repair. So repaired, initially the repaired cars, let's say it is 0. Now I have to iterate through all my mechanics ranks and I have to calculate this square root of time divided by the rank. Okay, so and then I have to basically do the summation, right? So repaired cars, okay, is equal to the math dot square root of time divided by the current rank. Okay, and I should basically, yeah, let's also typecast it into long. Okay, and we are actually adding it to repairs cars. Okay, if the number of cars which are repaired, if it is greater than or equal to the cars repaired, that means I can actually repair the given number of cars, or else I cannot repair, right? This is basically if for a given time t, if I repair 5 cars, but ideally I have to repair 10 cars, that means I cannot repair. Okay, now that if I, for a given time t, I know the total number of cars, whether I can repair the given number of cars or not, right? If I can repair, then I have to actually look for a lower time, which lesser time, right? So I have to basically search in my left half. Okay, so in that case I have to update my right pointer to mid -1, and let's also have long min time. Initially the min time would be equal to the right. Okay, this is the maximum time which it can take, and then the min time is actually equal to mid. So this could be my potential answer, right? If I can repair, that's the reason my min time will be equal to mid, and I have to search in the left top to find a lesser time, right? And if it is not if in a given time, if I cannot repair, if in a given time if I cannot repair all the cars, then I have to look for a time which is higher than the current time, which is higher than the mid. So I have to update my left pointer to mid +1, right? So once this entire execution will be done, all I have to do is to return my min time, right? Okay, yeah, let's try to submit our solution. Yeah, basic test cases were passed. Let's try to submit it. uh, let's see. It has also satisfied all the test cases. Okay, so the idea here is to apply the binary search in the range of the time. Okay, and check whether the number of cars repaired is actually greater than the cars which are desired to be repaired, right? That is the thought process. Okay, I hope you are able to understand the explanation. Do let me know in the comment section if you have any queries related to the problem. Okay, thank you. Do subscribe to my channel for more such coding videos. I will be posting one coding video every day. Okay, do follow me to keep your coding skill up to date. Thank you.